Many organizations in the federal government have the need to share image services between agencies and the public. This can occur during daily business operations as well as in times of emergencies. The new ArcGIS Image for ArcGIS Online provides hosted imagery capabilities along with visualization and raster analytics in the cloud. Last year, approximately 10,000 fires burned more than 4.3 million acres in California. To understand the impact and severity, we'll analyze the area near Santa Rosa using the new ArcGIS Image for ArcGIS Online. For our analysis, we'll be using a collection of satellite images that cover this area. These images that I currently have locally can now be hosted directly to ArcGIS Online. Let me show you how. Images can be hosted as static tiled image layers or dynamic imagery layers that support dynamic mosaicing and on-the-fly server-side processing. From the interface, users can select the layer configuration, choose the data type, and fill in additional information such as the processing template and more. By simply dragging and dropping the image files and their metadata, and filling out the item description, these image layers will now be hosted in ArcGIS Online. Fast forwarding a few minutes, once the data is uploaded, we can add it to our map and begin our analysis. This is an image near Santa Rosa after the fire. By changing the band combination on the fly, we can now have a better look at the impacted area, indicating loss of vegetation in orange. We'll continue our analysis by applying a raster function template, which will classify the area by burn severity. The raster function editor in ArcGIS Online provides 153 raster functions out of the box that can be changed to create a complex model. These raster function templates can be shared and used across desktop, enterprise, and now even on ArcGIS Online. Once the template is loaded, all you have to do is click on Run Analysis to get your results. In the interest of time, I have it generated in advance over 3,000 square miles. The high burn severity is shown in orange and lesser severities in other colors. Now, one of the questions that you might ask next is how many structures were in the path of the fire? And if you didn't have the building footprints previously mapped, we can leverage the deep learning capabilities in ArcGIS Online to extract the building footprints. To get started, let's go to the new raster analysis tools, select deep learning, and in our case, detect objects using deep learning. Using high-resolution worldview imagery provided by Maxar, and going to the Living Atlas, we can select from a library of ready-to-use deep learning packages that include land cover classification, road extraction, human settlement detection, and more. For our use, we'll select building footprint extraction. Let's take a look at the results. The model was able to extract tens of thousands of building footprints in just a matter of minutes. We were able to determine the number of buildings within the burn perimeter. This was just one example of using ArcGIS Online with hosted imagery. Now let's take a look at a different topic and at a national scale, conservation. The 30 by 30 initiative is about preserving 30% of our lands and oceans by the year 2030 to balance the physical, biological, and cultural assets of our environment for a sustainable future. Here are the areas already protected within the US. Roughly 12% of the lands and 23% of the oceans correspond to an assigned GAP status 1 and 2, which requires permanent protection of its natural state. Overlaying managed federal lands, we can see a broader area covered, color-coded by managing agency. In order to achieve our conservation goals and reach 30%, we may want to identify areas of the federal land suitable for additional protection, and new areas across the US with a high priority in our conservation efforts. To answer the question where to focus our efforts, we collected available resources on the Living Atlas to build a national inventory of information layers, which will help us define the characteristics across the US. The first example dataset is NLCD, Natural Land Cover Dataset, created by multiple federal agencies using different variables like vegetation type, agricultural use, and development density. The next dataset, created by conservation scientist David Theobald, shows human modification across the US. The darker the red, the larger the human influence on the area. The third example shows biodiversity importance generated by NatureServe. The brightest colors indicate where multiple imperial species occur and are currently not safeguarded. These are just 3 examples of the information that we loaded into ArcGIS Image for ArcGIS Online to create a collection of 27 layers describing the land characteristics across the US. Using raster analytics, we created the first national map of minimally disturbed natural areas, also known as green infrastructure. This layer is not just a visual description of the location, but also an information-rich dataset that allows us to perform analytics and help us answer where to prioritize our conservation efforts. Conservation priorities are not always the same for everyone, and as a result, it requires input from multiple stakeholders. This web application allows us to leverage the benefits of the dynamic imagery layer and help us narrow down potential conservation areas based on different scenarios. Let's assume that we would like to expand the conservation areas around Yellowstone National Park. Looking at the federal lands, the immediate vicinity is managed by the Forest Service. So we'll prioritize forests and biodiversity for this scenario. The result of this analysis is a weighted overlay, highlighting areas of high conservation priorities in dark green. Now let's take a look at a different scenario, prioritizing wetlands instead of forests. We can change the weights and get an alternative answer. Let's try one more. Wildlife conservation corridors. When we start to look at this from a larger context, we can discover the natural network forming pathways across the US, like this one that connects from the Grand Teton to the Upper Green River Valley and south into Colorado, which happens to be the largest pronghorn migration corridor in Northern America. As most of this corridor falls around BLM lands, this analysis shows possible areas for additional federal conservation and protection. These were just 2 examples of ArcGIS Image for ArcGIS Online providing managing, hosting, visualization, analytics, and sharing capabilities at any scale, conveniently and efficiently in a software as a service environment. Thank you.